So Esther Dyson, it's hard to even describe all the amazing things that she's done. She started in digital media, she moved into digital health, she's been a cosmonaut, she's in many ways lived the life that we would all love to live. Whatever she is interested in doing, she goes out and pursues with a vigor and a passion. And her latest, also an investor, her latest venture is something with the peculiar name of Hiccup. And Esther, tell us about Hiccup.
Okay, I also have to add that, and is it working? Yeah, that I am number 3 in George's Personal Genomes Project.
And I'm number 13.
13. And to some extent, what we're all trying to do is not just generate data for science, but also to make it seem not weird to have all your medical and your genetic data out there. Nobody's taken my data and made a little thing and pricked a pin through it. So it's important. No voodoo. Hiccup stands for Health Initiative Coordinating Council. And you heard Peter Diamandis yesterday. There's the X Prize. There was an X Prize for health that never happened. There was also the Archon Genomics X Prize that never happened, unfortunately. There's the tricorder one that is happening. I wanted to be a judge for this Health X Prize. This was 4 years ago. It was funded by WellPoint, and it never happened. And I kept thinking, wow, this is so great. Somebody should do this. It would be really nice. 5 communities competing to win a prize for increasing the health of the community at lowered cost. It would be great for all my cute little companies. They could try out their interventions or their tools. It would be great for science. You'd generate a whole lot of data. We've heard all this wonderful stuff, but how and when does it apply to real people? There's a lot that we can do with existing technology. We don't need to know our genomes. We don't need high-tech medicine. We need better diet. We need hand washing in hospitals. Why doesn't somebody do it? And I was giving a talk, I was trying to think about what I would talk about. I thought, well, I can talk about why doesn't somebody do this X Prize, but it seemed kind of lame. And I realized that I would do it. So I spent the last 6 months learning what it was I've committed to doing and trying to understand what you actually can do in a community to improve its health, and trying to find 5 communities that have not just the people who are not necessarily sick but unhealthy, but also enough social cohesion to actually make it happen. The goal of this project is for 5 years, these communities to compete, generate a huge amount of data, which is public, although personally de-identified mostly, create inspiration, create role models, create data, and make themselves healthy. So that's the basic idea.
So why did you decide to do this? You're mostly known for being a technical person, but I find it fascinating that you're really going, it can be low tech, right?
Yeah. Well, in some sense, I wanted to do something that had real impact immediately, that was not simply low tech, but also low income. And I'm in a very interesting position. I know lots of important rich people. I love all this high-tech stuff. I know amazing stuff. So I'm really not the right person to run a project, and I did go out and find an executive director. But it seems to me that the biggest problem with healthcare is not the health care, it's the fact that people need it. And if you go in right at the beginning, and you start with children and diet, as well as fixing the healthcare system, you can have a huge impact. And if you're rich and you don't care, your taxes are paying for all these people you don't care about. So whatever your motivation, this is probably the thing that's going to make the biggest difference to the largest number of people. Yeah. And that's why.
So how do we connect up the two of you? What we're doing, what you're talking about out in the community. And, George lives in the future. I'm not sure how far out. But.
No, he lives, part of the point is he lives in the present. I mean, whether it's mercury exposure or some of the, part of our business model is you take the very expensive, very ill people and you make them less expensive by treating what they've got rather than simply dealing with the implications of it.
Yeah, yeah. But I mean, well, George is living in the present and various stages of the future.
Thank you. Now you corrected
yes,
it.
Yeah, there we go. But so, I mean, the same question though, really. I mean, how do you connect up, all the cool stuff that you're doing, that we're talking about at this meeting? How do you get that to, especially, most people here are people of means. How do you get it out to the general public? And I'm even maybe thinking, you probably someday, hopefully, will do a Hiccup maybe in the developing world and some other parts of the world.
No, they'll do it.
Or they'll do it. Yes, no, not you personally, but I mean,
Right.
one will do it.
Yeah.
And that's an even bigger challenge because many people, even though you might have a Maasai warrior with a cell phone, I've lived in that part of the world, and they also go back to the hut that they live in. And in fact, I wonder how.
But at least he doesn't have McDonald's.
Not yet. That's a whole nother wave of problems. But George, what do you see in what you're doing right now that could be applied to what Esther is doing? I mean, if you had something you wanted to go test in one of her communities, what would it be?
Well, so I think one of the prerequisites is reducing the costs, which we are doing dramatically more than ever. So the cell phone that you mentioned is a good example where you go from something that is only for the elite to something that really is increasingly accessible. And the second thing is education. You need to have pretty full-on education. My wife has a project called pged.org. She's a full professor of genetics at Harvard as well. And we're testing out various ways of educating high school students and physicians and so forth. And it was really high school that helped us get the internet going, right? If you had a question, you didn't go to your pet computer scientist, you went to your teenager. So that's part of it. But part of it is a community effort, a prize, or just any kind of effort to get communities to compare notes without a prize is a really great opportunity. It gets the education and the costs down and injected into society. You need to work with companies to do that. I mean, you can't just go from an academic publication to a community. You have to connect the dots with companies.
Yeah, and I wonder, do technologies that we're talking about here, we always use the cell phone and the personal computer. I mean, I can remember when a cell phone cost about $10,000 a month and it barely worked. And we have these constant examples. And yet, medicine also has, of it getting cheaper and easier and more accessible. But you also have an example of where medical technologies get more and more expensive. And when you're talking about some of the actual, and we've seen some of that here, and we'll see some more of it over the next couple of days. I mean, new surgical devices, things like that. How do you connect up those two in are those trajectories? I mean, will we really get a trajectory of these technologies getting cheaper? Is this true, in your guys' opinion?
Yeah, it's very curious to see simultaneously precipitous decreases in costs and then increases. I think some of the increases is partly because our standards are going up. We used to be much more accepting of OBGYN doctors delivering with dirty hands and causing a lot of death. But I think our standards are going up, and when people worry about 18% of our gross domestic product going to healthcare, I say, well, what else would you spend it on, right? I mean, it's very important.
I mean, if you actually kept people healthy, I would spend more. The issue is we spend too much keeping people alive but unhealthy,
right.
And we spend too much on drugs that could, some of them do good stuff, some of them, again, we spend way too much fixing stuff too late. But I want to go back to the education thing. I think, so in our communities, we'd love to have the kids have non-invasive glucose monitors and all kinds of things, and have them learn science and physiology and medical stuff, not out of textbooks, but by trying things on themselves. I mean, doing the quantified self, not wearing a Fitbit every day for 5 months, but eating a carbohydrate-filled lunch and testing their blood glucose, looking at the impact of their behavior on their C-reactive protein. I don't know what, but there's nothing more fascinating than N of 1, and that's getting cheaper, and that's the real revolution.
So do you think the world that you invest in, that we spend a lot of time in, is it connecting? And why do you need to even do Hiccup? Why isn't it being done a million times over?
Exactly. I think somebody needs to do it, and then other people will copy it. I hope they will. And so Hiccup, the purpose of Hiccup is to become unnecessary. Yeah. But there's a lot there, not about I am going to choose better food, but better food is going to be available to me as a default.
And I did want to talk...
And that's the subversive part.
Yeah, yeah. I think I have to peer over this monitor to see the time. We have surprisingly little time. Yeah, is this
I thought we were
right?
supposed to end at 6:45.
Yeah, I thought...
Oh, maybe this was our section.
I'm not really sure.
Yeah,
I think we have another 15 minutes.
Yeah. This is just, you're in my section. So.
Right, okay.
And we can also ask the audience to chime in.
We're having a little logistical discussion. Yes, in about 5 minutes we're going to bring you all in.
It's the interpretation of the data that is the big problem here.
Yeah, exactly. We're trying to interpret our clock right now. Let's talk a minute, though, about personalized medicine itself, therapies, treatments. What exciting is happening in that world? And I'm thinking about things like companion diagnostics. You work in that world as well, don't you?
Yeah.
Is it really happening? I mean, I got to say, as a journalist, every few years there's a new pop phrase that comes up. It seems to be precision medicine right now, but it's kind of the same thing. We keep circling back. Can we get away from what I was talking about, and we were all talking about here, from a world of one-size-fits-all medicine? But what exciting things are happening right now?
Well, what you just said about warfarin.
Yeah.
The ability of every kid to check his own blood sugar, to understand what their behavior is doing. The ability not simply to look at your weight on a scale, but to actually look at the proteins, your microbiome, all this kind of stuff is fascinating. And it's not simply treatment, it is understanding what happens so that you don't need treatment.
Yeah. And I'm expecting revolutions to occur fairly quickly. Like the microbiome, it's amazing. I could not sell a microbiome story to an editor 3 years ago. People look at me like, what? What's in my gut? I don't even want to know. And now suddenly it's it's a cover story of every magazine.
I thought the inside of your ear was more disgusting.
That's true. I know when Eric Topol showed the inside of Colbert's ear, I really like Colbert, but I didn't really need to see the inside of his ear. But from your perspective in your lab, what is the most exciting?
Yeah. So I think pairing diagnostics and therapeutics, that will continue to happen. But I think therapeutics is too reactive. It's like in surgery and all this end-of-life stuff, way too reactive. We need preventative. So not only personalizing your drugs, but personalizing your diet. I mean, milk is not good for everybody. Meat is not good for everybody, but it's not bad for everybody either. Fava beans, wheat. You don't have to all be on a gluten-free diet, but some people do. But the other thing is, we have an increasing ability to change our environment and other preventative things. I mean, the gene therapy, I think, is still a ways off, but if we can really take an active role by monitoring very carefully, and that's a new thing. And the microbiome, something we're doing in our lab and also in a company that I've started called Series, is making that a more reproducible process by which you can have very serious problems like Clostridium difficile or a whole variety of other diseases that are a reflection of the sort of thing that Larry was showing. Control your diet, but you can control your microbiome directly. Controlling through your diet is ineffective for the most part, but you can do it directly.
Yeah. By the way, why don't you guys start lining up anybody that has additional questions? So hopefully we'll get some of you involved here.
Related question, and it's on the heuristics of understanding mortality. And if you look at sort of random mutations and the diversity of the genome, and you look at the relatively rigidly controlled lifespan, plus or minus 10% for any individual species, even within a genus, It suggests to me that, with the possible exception of Methuselah, that there must be multiple redundant, profoundly effective mechanisms that lead to programmed death, because a mutation in one or two of them would be insufficient to create exceptional long longevity. So is there anybody who's done any modeling to try and understand how many redundant mechanisms there are to ensure that an individual species does not significantly outlive its genetically programmed lifespan?
Yes, so there are some models. I think maybe more interesting way of looking at it is we know that there are hundreds of genes involved in human height. It's very complicated, and height is also very characteristic from species to species. That said, you can find extreme individuals who are giants or are quite small, and that means that even these complex phenomena are crackable, and there are human individuals. Used to be the lifespan of our species was like 27 years, and there are individuals that live to 122, which would be a different species by most criteria. So I think we want to embrace those highly exceptional individuals and figure out what happened. Because, in the case of height, it might be the human growth hormone, which is a really fantastic discovery. It's applicable to people who aren't even damaged in their human growth hormone.
Yeah. Okay, we need brave people up here.
Here's one.
Oh, okay.
Well, no.
Oh, well, I don't know how brave Jamie is, but yeah.
He's also 160.
Yeah, he's at least 160.
You don't look a day over 100.
In the Jeopardy context, since I've been accused of not asking things in the form of a question before, David, you had a great slide that talked about the complexities from regulation, and George, you just referenced complex integrated phenomena. So can we just talk for a minute, not to sort of bring the room down a little bit, but I mean, the belief in this future where all these networks converge and we understand this is great, but can you tell me how, in the next few years, given our current medical system and reimbursement mechanisms and our pharmaceutical manufacturing and delivery mechanisms, we can begin to make some real progress? Because I am, to my mind, skeptical that the system is more resistant to change than we believe, not even adding the regulator. So give me the answer, please.
Well, I think the first thing that you do is you go around that as much as possible. And in fact, that's part of what we're talking about here. It's a little bit guerrilla, a lot of disruption. I mean, that clearly is the powerhouse of how medicine is funded, the reimbursement system, the way the structure is set up. But I think what we're all exploring here is how to create new structures around that.
But I don't think you necessarily go around the FDA. Safety is not a bad thing. If it takes 10 years to get something approved, then that's how long it takes. To bring out a bold new mode of transportation also takes a long time, as it should. But I think overall the FDA embraces innovation despite its reputation. That someone showed the drugs that send a radio frequency once they hit your stomach. That's a bold new technology that was approved fairly swiftly. And there's a drug that treats a particular allele of cystic fibrosis, very, very specific, and that made it through in about 3 months of FDA scrutiny. Yeah. So they're not a serious roadblock, in my opinion, and we should embrace, and we should start making technology that really rocks. I mean, that's very safe and very efficacious.
Yeah,
and it's perfectly feasible.
I would say that probably the bigger deterrent to progress is not even HIPAA itself, but interpretations of HIPAA, and the unwillingness of people to share data, to use data, which we've been talking about a lot today. But the FDA may slow down some things for safety, but there's self-experimentation, and I would encourage that.
One interesting solution to HIPAA in terms of sharing that Esther may be alluding to, that we use in the Personal Genome Project, is that you can get your electronic medical records transferred into your personally controlled health records. At that point, it's no longer under HIPAA control, and you can do whatever you want with it. And that's the mechanism that we use for sharing medical records that are essentially identical digitally to the EMRs, but the PCHRs are shareable.
Yeah.
And if that's what's required under HIPAA law, then that's what we should do.
And more people should do it.
In fact, this what I mentioned really quickly. You could devote a whole section on the need to adapt rules, regulations, the politics behind that. What happens in the rest of society with that's not involved with technology? How they absorb these things? I mean, we really do have this archaic Byzantine healthcare system in so many ways that's trying to keep up with what we're talking about here. And I encourage you all, in fact, to think about how to interpret and improve those areas with as much energy and passion as the technology. Anyway, Dean?
Dean. You're there. Just talk.
One, two. There we go.
There you go.
Just a side note and then a question. George, you were talking about, or someone asked you about telomerase. In my lecture, which follows this panel, I'll be talking about how lifestyle changes alone increase telomerase by 30% in just 3 months. And we recently published a paper in the Lancet Oncology that the telomeres themselves extended by 10% over a longer period of time. So even simple lifestyle changes can affect these kinds of processes. But my question was, David, you showed a slide about mercury and how it looked like there was no effect, but when you looked at people based on their genomic subtypes, that you actually did find an effect.
Yeah.
And I know this is politically incorrect, but is there anybody who's looked at vaccine and autism in that way? Because if you talk with parents of kids who are autistic, they're so committed to believing that that's true, and whether or not that's true, there's been studies that taken as a whole, you don't see that, but are there subtypes of people for whom being exposed to a lot of vaccines early on might have a bad effect?
Well, I will say it is actually very difficult to talk about mercury and autism in the same sentence with all the controversy around vaccines. But we actually do have some mechanistic data, which we're not making public at the moment, but at least one of the genes that we're working on does have some connection with a potential cause for some forms of autism. So yeah, I mean, and the mercury augments that particular effect of that gene. All right, let's give a hand to our panel here.
This is great.
Thank you. Thank you.
Thanks. I'm getting my